Hi, my name is Jackson Britsky, and today Matt Hurley, Aaron DeVere, and I will present our cybersecurity research project on behalf of our team, led by Aaron DeVere and Professor Chu. Today I'm going to go over the history of botnet, or what a botnet attack is, then I'm going to explain how our attack is different. I'll show you the infrastructure of our attack, and then Matt Hurley will go over the password cracking, brute force, and dictionary attack, and then Aaron will lead you through a demo, and then I will conclude with prevention techniques we can employ. Hackers use botnet attacks mainly to take over your computer and get valuable information. They do so by using a network, getting a network of computers and hacking it through malicious software. Once they're into your computer, they can use your computing capacity to unleash attacks, such as DDoS attacks, distributed denial of service attacks, which can block servers. Our attack is a little bit different because we're going to lead you to our website, which we're then going to send payloads to your computer, which will serve so we can use your computing power to attack your target computer. A simple client-server interface would be a client goes to a web address, our server searches up and sends you a web page. But what we're doing is when you access our web page, we're going to give you a web page, and then we're going to send payloads to your computer, which are going to run this JavaScript, which will then allow us to start attacking a target victim. Our goal is to crack a target victim's password using brute force and dictionary attacks. As shown, the clients will then attack our target victim through sending payloads to them, which will then attack through SSH connection the target victim. Now, Matt will show you the algorithms and combo attack.
All right, so we employed two different methods of attack in this project. The first one that we use is a dictionary attack, which starts off with a file that contains multiple passwords. Probably the smallest one we used had like 8 passwords, and up to one that we have that has over 14 million, which can also be used to gauge the relative security of the password you can search through. So that will pass chunks of passwords to each client that visits the web page to be tested against the server. We also created a brute force algorithm, as you can see at the bottom, which will start off with 5 A's and increment up through the numbers and letters, which uses a lot more passwords, but will be sure to get the password no matter what combination of letters and numbers it is. So using these two attacks, we will generate a list of passwords, and then we will chunk the list and send them individually to each client, which will then be used to pass those passwords and try those credentials against the server through the website.
So now we're going to go with a demo. So we have a very harmless instance of our server running. And what it's doing is it's just pinging the client. So when you're connecting to a website, you are a client, and the server is serving you a web page. The thing about our root server is that underneath the web page, it's actually sending you malicious scripts so that you can attack another person's computer. That kind of has a way to make sure that the hacker isn't caught. It makes it look like you're hacking another computer. And it is a very efficient way in terms of computer distribution, because the more people who are on our website, the more people are attacking a target computer. And actually, I'll go ahead and show you an example of the script we're running. So if you look in your web browser's console, you will see that we are passing a script that just says hello world, and you can look at the counter here that in just less than a second it's sending all these different commands to instruct your computer to say hello world. But that's just one type of payload. The payloads we're working on range from SSH attacks, and will feature the password cracking algorithm that Matt was just talking about.
So there are two main ways to prevent this kind of attack. The first is making stronger passwords. Basically, an 8-character password with numbers and asterisks will make it somewhat difficult, but the more letters and more characters you use, it exponentially makes it harder to password crack. The next and most simplest thing to do right now is when you're on a web page, you can go into your browser information and cancel JavaScript, so we cannot send you these payloads. What's next for our project is to finalize our SSH connection payload, which will allow the clients to directly, through SSH, attack the target. And if we vary and expand our payload capabilities, we can perform more destructive attacks. Questions?
The purpose of this is to help us, because people out there are fair, it's not incident and SLPs. So this is a exercise in showing to be careful, make sure the password fair. Or is there some good use for this, maybe the defense department? What's the purpose? Usually research in business school, we normally do like, what's the purpose of this research? Why is it needed? You're just hearing it, so even more than just hearing it.
Well, for a security standpoint, you want as much intelligence on up-and-coming threats. This type of attack has never really been used before because it exists purely in the web browser. Usually if a hacker wants to hack a computer, they use easier ways to do this. But this is a way that's hidden to the victim, and it allows for mass appropriation of the botnet. As far as further application, I mean, we're talking about very destructive payloads, but I could just as easily see the payload that we're inserting onto your computer contain demographic information about your computer that could be future used in advertising purposes. That's similar to what Google Analytics does. So this could just as much be easily used to attack a computer, but also maybe get information and insight into who's viewing a website and where they're going after you on this website that could eventually be used for advertising purposes.
Good questions.
So, like, what kind of hacking are we talking about? Are we talking about hacking email accounts, or hacking directly into the computer?
Well, SSH is mostly used in voice X and Linux operating systems, even though Windows has a way to access it. So you're talking about remotely logging into somebody else's computer as if you were the root admin. For instance, I can log into the server that is running this program through my phone through SSH, which is the type of attack we're talking about. The payload, when it gets executed in the web browser, will make that SSH connection to a victim computer, and in the long run, give whoever owns the server the password credentials to access their computer.
Any questions?
Yes.
How would you draw traffic to the original web page in the first place?
Actually, we have a fun little game that we came up with. Here's some of the researchers who designed it. But that's a great question, because the attack vector totally depends on the fact that they're on a web page. If they leave the web page, then they can't get the attacks that we're sending. So if you were to launch this attack, you would want a game. You would want something that would keep a user on the web page for a long time. BuzzFeed quizzes would be a perfect example of that. You just want to maximize the amount of time that someone is spending on the website to launch the attack. And there's some speed tests that we run to successfully launch these attacks. You can have one person on the web page for a long time, or you can have a lot of people on the web page for a shorter amount of time. So there's some maximization experiments that we ran on that. Of course, it depends on how big the payload is, which is our biggest challenge right now. Thanks. Yes.
How comparable is this attack to recent ones, such as the recent Superfish man-in-the-middle attack that affected several Lenovo computers in the past year? Is this very similar? Is that a real-world application of it?
Well, actually, speaking of an adware payload, the Lenovo man-in-the-middle attack was adware. it wasn't intentionally malicious. They were actually just trying to pick up advertising details from their customers. So in that sense, it's pretty similar. The fact that you could just as easily insert a business purpose program for a malicious program. We've created a platform that's totally modular that you could just pop in one program that says hello world, or you could pop in a program that starts spitting out what you're typing into your computer. So it's very similar.
Also, like most security, like whenever you're trying to hack into something, when you try to log in more than like a couple of times, the account shuts down. So, like, will this work on like like is that security measure gonna like stop you guys from hacking into that computer?
This technique that we used, the SSH cracking, actually bypasses the security features that the SSH protocol has for that. As far as like hacking emails and such like that, where you have something else, I'm not sure how that would work. But with SSH, we are able to bypass that.
Yeah.
Why is the focus of your research on doing a hack or an illegal hack as opposed to solving a hack or illegal action? I'm a little confused as to why your research is focused on doing something that's illegal.
Well, actually, some of the biggest security professionals go to illegal hacking conventions such as DEF CON to learn about up-and-coming threats. Basically, you can't really defend it against an attack unless it's well-known and unless it's been well-researched. So by inventing this type of attack, we can begin the process on how we can prevent it. For instance, this attack would not be possible if JavaScript was not enabled in your browser. When you go to a web page, it's open for JavaScript compilation. If you turn off JavaScript, then this type of attack can never happen. So maybe this can be the first step in a conversation on better JavaScript security in web browsers, or perhaps more secure web pages that can see that, hey, there's all these scripts being run, maybe this is a malicious website. So a lot of different security projects run by Google and Google Chrome kind of have these sensors that can detect that all these scripts are being run and start to turn off the access to those codes. So, I mean, when you talk about why you do certain hacks or whatever, usually the long game is to better understand it and then defend against it rather than exploit it.